Good morning, students. How are we this morning? I'm your usual technical drawing teacher, Mr. Albert Awoliman. May God bless us all. We should be having a revision of your last term work online this morning on the topic equal area of plane figure. We'll precisely be looking at a rectangle and triangle that are equal in area. That is constructing a rectangle, constructing a triangle, both of them having equal area. Before we talk deeply, let us quickly look at the objectives or what we intend to achieve in course of this lesson. That is, at the end of this lesson, you should be able to construct a triangle, construct a rectangle equal in area to the triangle. Then the last thing is you should be able to use mathematical proof to justify their equality. That is, the value of the area of the rectangle and the value of the area of the triangle being equal. We now move on to the content of what we have. What is a triangle? In our SS1 week 1 work of first term rather, we discussed about the triangle, and later on we also discussed about quadrilateral. That is plane figures having 4 sides or 4-sided plane figure. So a triangle is a plane figure bounded by 3 sides and angles. I come again, it is a plane figure bounded by 3 sides and angles. Remember we said it could be equilateral, could be isosceles, that is having 2 sides equal. It could be scaling, having none of its sides equal, as the case may be. Then a rectangle on its side is a plane figure or a quadrilateral bounded by 4 sides and angle. A rectangle is one of the examples of quadrilateral. We want to have this as quadrilateral, precisely a rectangle constructed from a triangle, and both the triangle and the rectangle having equality. The triangle could be an isosceles, could be equilateral, as you wish to do. The steps involved in drawing a rectangle equal in area to a triangle. What are these steps? First, you draw the given triangle. Here I call it ABC. You can name your own PQR, XYZ, CDE. But remember, the alphabets should follow sequentially, not that you use A, you use D and E. It shouldn't be ADE or YSZ. That is random. It is not sequential. It should follow in a good order. Then next thing, you draw a perpendicular line. That is a perpendicular line to AB from C. That gives you a point called D. Then the next thing, that line CD is always a light line or faint line, not bold or thick. You bisect it at the right hand side and at the left hand side. Then after that, you draw perpendiculars at A up and at B up. That will mean the bisector of the triangle, or the bisector of the height of the triangle, or the bisector of the CD line. That is the line that the perpendiculars from A and from B will meet. Wherever it meets that line, it becomes point E and point F, respectively. Then what next you need to do is to make that line bold. Let us quickly look at some of these things I'm discussing here, so that it won't look as if, you're just talking. Let's look at some of them. This is a triangle that is being bisected. This is point A of the triangle at the base of the triangle. This is point B of the triangle at the base of the triangle. So line AB is a horizontal line and is the base of the triangle. Then the top here is point C. So remember we said, draw a perpendicular CD. That is from here, you take a line down to meet AB here. That line divides AB into two equal parts. That point becomes automatically D. This set square, the way it is positioned on the T square, it is lapping at an angle of 90 degrees. That is to take a perpendicular line. This time around, not 30 or 60 degrees angle. You can see it very well the way it is placed on the T square. That is drawing the perpendicular line CD. After that, you have the perpendicular line drawn. Just see it here. It is being produced. Line CD. It is faint or light, as I've told you. It is not a bold line, but it is seen inside. It is that line that you will now bisect. That is, you can use the radius CD to bisect at this side. You also bisect at this side. You can extend it D upward after C. Then you bisect at this side. You also bisect at this side. That is bisecting line CD. But you place it at C, you will cut. You place it at D, you will cut. You also place it at C here, you cut. You place it at D, you will cut. You have bisected line CD. Then where the arc meets at the left-hand side and where the arc meets at the right-hand side, you use a light line to join them together. You join them with a light line. That is what you will see here. These are the arcs that are being drawn at the right-hand side and at the left-hand side. The arcs are being produced. Then you use a light line to join them together. That is the next thing you are seeing here. The light line moving from this meeting point of the arc, going to this meeting point of the arc. That is a light line. Remember, your triangle is the only thick object, or it is your triangle alone that will make bold in this case. Now, after this, the next step is to draw perpendiculars from A, taking it from here up to meet this line here. Anywhere it meets the line, you stop. You can give a light line to continue, but from here, from point A to this point, you make it bold. Then from point B to this point, you also make it bold. That is the perpendiculars at A and at B. That is the next thing we need to look at. That is drawing the perpendiculars at A. This one particularly is at point A. You take it up. See also the set square is positioned 90 degrees to the horizontal. You start from here, make the line bold. When you get here, you stop. That becomes your point E automatically. You have gotten A, you have gotten B, you have gotten C top here, you have gotten D. This one becomes point E. You also turn the set square to this side, the other way. Then you take it up here. When it meets this point, it becomes a point F. You have gotten E and F now. So EF is one of the sides of this rectangle. That is one of the lengths equal to AB. That is what you are saying here, or what you are saying here is the second perpendicular line drawn from B, taking it up to meet this line here, the bisecting line. That gives you point F. Then you now join EF together. That gives you the triangle, the rectangle that is produced from the triangle. This triangle that I've drawn, produced here, is an isosceles triangle, having base of AB 80 mm, then AC 70 mm, then BC 70 mm, isosceles triangle. Then the height here, that is line CD, automatically is the height of the triangle. That line CD, I measured it to be 5.6. You can use any of the values of the sides of the triangle. You will still get the same thing. In this example, line CD is 5.6 centimeter, while line AC is 7 centimeter, line BC is 7 centimeters, line AB 8 centimeters. Then the length of the rectangle is AB 8 centimeter. This breadth BF is equal to AE. I got 2.8 centimeters. So to prove this, what we have done is From the triangle, you know that area is half of the base times height. We said base is 8 centimeters, as I've explained. BC equals to AC because it's an isosceles triangle. You know that. There's 7 centimeters they are. CD is the height. That is 5.6, like I told you, is what I measured there. Mathematically, you have half of base times height. That is 1/2 times 8 times 5.6. That gives you 22.4 centimeters. That is the area of the triangle. Then let's go to the rectangle. The length is AB or EF. That is 8 centimeters or 80 mm. Then the breadth is AE or BF. That is 2.8 centimeters. 2.8 multiplied by 8, that is length times breadth, will give you 22.4 centimeters. So you can see that 22.4 is also equal to 22.4. That is the quality of the work we are talking about, or the quality of the areas of the triangle and the rectangle. They are equal. You've seen from the proof. Remember, we said a triangle has 3 sides and angle. It's a plane figure bounded by 3 sides and angle, while a rectangle is a plane figure bounded by 4 sides and angle, or a quadrilateral bounded by 4 sides and angles. We've also said that to construct a rectangle equal in area to a triangle, you first of all draw the triangle. Then you draw perpendicular CD at the top down to divide AB into 2, that is CD. Then we said the next thing you do is to draw perpendicular, is to bisect CD at the right hand side and at the left hand side. That gives you a bisector or a light line that will divide like CD into 2 going horizontally. Then you now draw perpendiculars from A to meet the bisector, then from B to meet the bisector. That produces the rectangle. Then you take the proof to see that half of the base of the triangle times height will give you a particular value mathematically. Then length times breadth of the rectangle will also give you a value mathematically. You see that from our example here, they are both equal. For your assignment, please check on your notes that is given to you for this particular topic. Your assignment is there. Please do the assignment properly. Thank you very much.